Hello, geometry friends. Today we are going to talk about trapezoids and some of the rules for trapezoids. So let's get moving. We are on day 3 of Unit 6, probably, which is currently on page 13 in your packet. But if I decide to use this video again, those two things might not be true. But it's still a video about trapezoids. So what we have now is we've talked for 2 days about triangles, okay? And on the second day that we talked about triangles, we took a triangle and then we found the midpoint of both sides, and then I drew in this thing that was a midsegment. And if I were to shade the bottom, this thing right here, I would have a trapezoid down there. So that's part of the reason that trapezoids come next, is because we kind of built one accidentally when we were talking about midsegments before. All right, so what the heck is a trapezoid? A trapezoid is a quadrilateral that has exactly one pair of parallel sides. Okay, so in this picture, BC is parallel to AD, but BA is not parallel to CD. So that's what makes this a trapezoid. Now, the things that are parallel are called the bases. So the parallel sides are your bases. So this is technically a base up here. We'll call that base 1. And this would be base 2. And the legs are the non-parallel sides. So this would be a leg, and that would be a leg. Okay? There are 2 pairs of base angles. Because I have 2 bases, this would be a pair of base angles. And these 2 up here would also be base angles. Okay, and I got to be honest, we don't use the term base angles all that often. We do a little bit, but basically the 2 angles that touch one of the parallel sides is a pair of base angles. So in this, it would be A and D and B and C. Now, just like within triangles, I can have a trapezoid, that's isosceles. An isosceles trapezoid has 2 congruent sides and 2 pairs of congruent angles, very similar to what a triangle has. So an isosceles trapezoid has 2 congruent legs and 2 pairs of congruent base angles. All right, so what does that mean? Well, this thing right here is an isosceles trapezoid. And in an isosceles trapezoid, this thing is going to be equal to that thing. And these 2 angles will match up. And these 2 angles will match up. All right. And those things I just talked about are part of the isosceles trapezoid theorem, so we're really just going to write it again. If a trapezoid is isosceles, then each pair of, where is it? If a trapezoid is isosceles, then each pair of base angles are congruent. And if a trapezoid has a pair of congruent base angles, then it has to be isosceles. In other words, just like with triangles, if I tell you it's isosceles, you know that the base angles are equal. And if I tell you the base angles are equal, then you know it's isosceles. It goes both ways. A trapezoid is also isosceles if and only if its diagonals are congruent. Okay? Therefore, isosceles triangles have congruent diagonals. And this last one works both ways as well. If you know it's isosceles, then the diagonals are congruent. If you know the diagonals are congruent, then it has to be isosceles. Okay? And your diagonals, just to make sure you understand, would be AC and BD. All right, let's use it. Now we're just going to use this to find some numbers and algebra and practice. So if HEF is 70, so from H to E to F, this thing right here is 70. And FGH is 110. That would be right here. Is the trapezoid isosceles? Explain. Okay, well, how am I going to figure that out? Well, if I know that these are parallel, That means 70, and this angle right here would be same side interior angles. Because if I were to like extend this and make it look like two parallel lines cut by a transversal, you can see that these two things right here would be same side interiors. And the rule is when lines are parallel, same side interior angles are going to be supplementary. So if I do 180 minus 70, I get 110. So that's going to be 110. And then the same thing over here. These are same side interiors. So those also have to 180, add to 180. So that makes that 70. Okay? And then wait, look at that. Both pairs of base angles are congruent. That makes this isosceles. So if I had to explain it, I would say EFGH is isosceles because both pairs of base angles are congruent. We used same side interiors, which are supplementary, to find all angle measures. Now, you really don't need that thing in the parenthetical, but I figured it's probably good to put in your notes, so if you're looking back at it and going, wait, how did I know that other one was 110? When you have a trapezoid, since you have parallel lines, the top angle and the bottom angle are always going to add to 180, okay? All right, let's move on. Now, what about the trapezoid midsegment theorem? Trapezoid midsegment theorem. Well, wait, a midsegment. We've talked about those before. Midsegments of a triangle are something that connects two opposite midpoints. Same thing in a trapezoid. If I draw a trapezoid and I find the midpoint of AD and call it M, and the midpoint of BC and call it N, and then I connect them, I get another midsegment. This thing right here is the midsegment. Okay. The rule about a midsegment in a trapezoid is similar to the rule about that thing in a triangle. It has to be parallel to the bases. So now I have 3 parallel lines, and its length is 1/2 the sum of the bases. So the midsegment is actually the average of the top and the bottom. You add AB plus DC and then divide by 2. Okay, and if you want to write it in words to help you remember it, it's top plus bottom divided by 2. Now, how's that work? Well, in this diagram, MN is a midsegment. Okay, so if MN is a midsegment, I automatically know that those are both midpoints, that this is parallel to the other 2, and they want us to find MN. Okay, so MN is going to be top plus bottom divided by 2. And 12 plus 28 is 40. 40 divided by 2 is 20. Cool. Here's another thing I want you to notice. So if they give you the top and the bottom, and you average them, you should get the middle. All right? One way to know if you did it right, and this is helpful in other instances, is 20 should be exactly halfway between 12 and 28. How much did I add to get from 12 to 20? I added 8. How much did I subtract to get from 28 to 20? 8. So depending on what they give you, it's helpful to know that the distance, I don't even want to call it that, but the distance on a number line from that midsegment to the top and the bottom is going to be the same. MN is a midsegment of trap. If RA is 12 and MN is 16, find TP. We're going to use that thing I just talked about. Since they already gave me MN, I'm not going to do top plus bottom divided by 2. They already gave it to me. So what we can do instead is use that thing I told you about where you just say, look, to get from the top to the middle, we added 4. So to get from the middle to the bottom, I'm going to add 4 more and get 20. That's it. Nice. And then number 4 says solve for x and y in the isosceles trapezoid that's given. Okay, so now we got a lot of stuff. I know this is isosceles, okay? And I know that I have a midsegment. So if I know that that's a midsegment, I know that these are midpoints, which means this is equal to this, and that's equal to that. But since I also know it's isosceles, I know that those two non-parallel sides are equal. So technically, all four of those can have a single dash because they're all equal to each other. All right, so now I got to solve for x and y. All right, let's deal with the mid-segment part first. So if I'm going to look at these, the mid-segment should be top plus bottom divided by 2. I can't do any light counting this time because I've got too many x's. So I'm just going to say the mid-segment is the top plus the bottom divided by 2. If I want to solve for x, I'm going to multiply both sides by 2. So now I have 14x equals 5x plus 18. And now I'm just going to keep going and solve. And get x equals 2. Solve for x. Done. Let's plug it back in to make sure it makes sense, though. That would make this a 10, and that would make this a 14, and that's 18. Add 4, add 4. I'm feeling pretty confident. Now let's find y. Okay, this is isosceles, which means that the base angles are equal. So if this is 64, that has to be 64. And if all these lines are parallel, this 64 means that this is also 64 because those would be corresponding angles. And if this thing is parallel to that thing, what kind of angles are these again? Well, they're both inside the parallel line and on the same side of the transversal. Those would be same side interiors. So I know that 5y plus 1 plus 64 has to add to 180. So that's going to be 5y plus 65 is 180. So 5y equals 115. And y is 23. Might as well check my answer. So if I did 5 times 23 plus 1, 5 times 23 is 115. 115 plus 1 is 116. So 116 plus 64, that adds to 180. It is what it's supposed to do. And that's it. I'm done. So there are 2 pages of some trapezoid practice in here. So the things that I want you to remember when you're doing this trapezoid practice is 1, if it's isosceles, like in number 1, left equals right, base angles have to be equal. And if they ask you about the diagonals are congruent also. Okay. One other thing I'm realizing right now, if yours printed like mine, this BD should be over here. So my apologies for that. Okay. Another thing I'd like you to remember is on number 2, it just says bris is a trapezoid. It doesn't tell me it's isosceles. So now my base angles don't have to be equal. But in every trapezoid, isosceles or not, 2 angles that touch different parallel lines are always same side interiors, which makes them supplementary. Okay. So just a couple things for you to remember. I am done now. You should be practicing this homework and then checking it with the answer key that I provide a link to. I hope everybody is having a glorious day and have a good one.